Welcome to the deep dive. Ready for another deep dive into some pretty out there science?
Always.
Well, today we're going to be talking about a potential future
Okay.
where we might not only have limitless clean energy,
Oh, wow.
but also
Okay.
the ability to tap into the consciousness of stars.
Fascinating.
Yeah, we've got some seriously mind-bending research papers,
Okay.
AI tutoring sessions, a lot to unpack.
I mean, what's so interesting about this is it's not just theoretical.
Right.
It's based on actual physics and technology that's being developed right now.
So we're talking about a potential future that's actually within reach.
Exactly.
I mean, imagine a world where we've finally cracked the code of nuclear fusion,
Yeah.
creating energy the same way that the sun does.
Uh-huh.
And what if through that same process, we could start to understand or even communicate with
Right.
the consciousness that might exist within stars?
Yeah. The key to this potential future is something called hybrid fusion. And it's a revolutionary new approach that basically combines two existing methods of nuclear fusion.
Okay, I'm all ears.
All right.
So what is hybrid fusion
Okay.
and how does it work?
So imagine using like a spark to light a bonfire.
Okay,
Hybrid fusion works in two stages.
good.
The first stage is using something called Muon-catalyzed fusion to kind of get things started.
Muon-catalyzed fusion. That sounds pretty high tech.
It is. Muons are these tiny subatomic particles,
Okay,
and they act as little cosmic matchmakers,
right.
bringing atomic nuclei close enough together
Yeah.
to fuse even at temperatures that are much lower than what's required for traditional fusion reactions.
So it's like the muon gives the nuclei a little nudge.
Exactly, to get the fusion party started.
Okay.
And then once this initial reaction gets going,
Mm-hmm.
it transitions smoothly to a more powerful and sustained reaction.
Okay.
And this uses magnetic confinement,
Ah, Tokavek.
similar to that.
Yeah, those donut-shaped devices
Exactly.
that contain the super hot plasma.
Yeah, you got it.
But how do you get both types of fusion to happen in the same place?
That's where the real breakthrough lies.
Okay.
So this hybrid reactor uses variable magnetic fields.
Okay.
So it starts with a low magnetic field strength,
Uh-huh.
ideal for muon-catalyzed fusion, and then ramps up the power
Okay.
to contain the much hotter plasma needed for the sustained fusion reaction.
So it's like having a dial
Yes,
that you can turn up or down to control the magnetic field.
precisely. This flexibility allows both stages of fusion to occur within a single reactor,
Oh, wow.
making the whole process incredibly efficient and
Yeah.
potentially much cheaper
Yeah.
than current fusion methods.
So that's really where the potential of this technology lies.
Exactly.
It's not just clean energy, it's about making it practical and affordable.
Exactly. You got it.
This is pretty incredible stuff, but we're talking about manipulating particles at the atomic level,
Right.
creating these incredibly powerful magnetic fields, controlling reactions that release tremendous amounts of energy. It sounds incredibly complex. How do you even manage all of that?
Well, that's where artificial intelligence comes in.
Okay.
So we're talking about an AI system that is so advanced
Uh-huh.
that it can manage this really intricate dance of particles and fields.
So it's like having a conductor
Yes.
leading an orchestra,
Yes.
making sure every instrument is playing in perfect harmony.
You got it.
Okay, this AI sounds seriously impressive. Is it anything like those thought experiments
Okay.
where a tiny being sorts particles to break the laws of physics?
Well, it doesn't break any laws of physics,
Okay.
but it does tap into some of the strangest and most counterintuitive aspects of quantum mechanics,
Okay.
especially a phenomenon called entanglement.
Entanglement, isn't that where two particles are linked
Yeah,
in a way that defies distance? So
exactly.
you do something to one particle,
Yeah.
the other one instantly reacts.
Yeah.
No matter how far apart they are.
It's amazing. It's that spooky action at a distance, as Einstein called it. And it plays a crucial role in how our AI manages the fusion process.
This entanglement concept is a little mind-bending, I'll admit.
It
It
is.
suggests that the reactor could operate in a way that seems almost, I don't know, telepathic.
Yeah.
So what are the potential advantages of that?
So the advantage is incredible control.
Okay.
This entanglement allows us to create a network of quantum sensors within the plasma.
Okay.
These sensors are linked through entanglement, meaning they can communicate instantaneously no matter where they are within the reactor.
So it's like having eyes everywhere inside the reactor,
Yes.
seeing everything that's happening at the quantum level.
Yeah, and it's even better than that.
Okay.
These quantum sensors use something called non-demolition measurements
Non-demolition measurement.
What does that even mean?
Yeah.
Well, it means we can observe the quantum world without actually disturbing it.
Okay.
So, like, being able to see the particles dancing without bumping into them
All
and
right.
messing up their delicate choreography.
That's incredible.
It is.
So, this entanglement allows for both monitoring and control of the fusion reaction
Yes.
with incredible precision.
Yes.
All thanks to this mind-blowing AI.
It really is.
But let's talk about the practicalities.
Okay.
How do you actually build this thing? I mean, muons are notoriously short-lived.
Right.
Creating and controlling those magnetic fields just sounds incredibly challenging.
Yeah, so the sources we're looking at highlight some pretty significant engineering hurdles.
Okay.
So, for instance, muons have a lifespan of only 2.2 microseconds,
Okay.
which is incredibly short.
Yeah.
We need a super fast system to move from muon-catalyzed fusion to magnetic confinement
Yeah.
before those muons decay.
So it's like a high-stakes race against time.
Exactly.
Yeah.
And then there's the challenge of creating different temperature zones within the reactor.
Yeah.
You need a cold zone for the muon-catalyzed fusion, a transition zone,
Right.
and then a super hot zone for the main fusion reaction,
Right.
keeping those zones separate without them mixing catastrophically. That's a major engineering feat.
Right. And then don't forget about controlling those variable magnetic fields.
Oh, absolutely.
Those fields are constantly changing.
Yes.
You need incredibly precise control over their strength and shape to keep the plasma stable.
You're hitting all the key points.
And the sources even use this term
Yeah.
to describe the level of control
Okay.
that we're talking about, Theurgic Wizardry.
It's true.
So it sounds like we're trying to be wizards,
A little bit.
manipulating the fundamental forces of nature.
In a way, yes.
It's not magic, though. It's science.
It's science. But it's pushing the boundaries of what we understand and what we're capable of
Yeah.
to create something truly extraordinary.
This brings us to perhaps the most mind-blowing aspect of all of this.
Yes.
Building this reactor sounds like an absolutely epic challenge.
Mm-hmm.
But if we succeed, the implications go far beyond just energy.
You're right. It raises these really profound questions
Yeah.
about our place in the cosmos. Like, what if this technology isn't just about harnessing power,
Yeah.
but about connecting with something far grander, like stellar consciousness?
Hold on. Stellar consciousness. Are we talking about the possibility that stars are aware?
Yeah, it is a pretty bold idea.
Yeah.
But one that I think is worth exploring.
Okay.
What if stars, with their complex quantum plasma and this incredible energy, possess some form of consciousness that we're only just beginning to grasp? And what if this hybrid fusion technology, with its quantum entanglement and its AI, could actually be the key to unlocking that connection?
Whoa.
I know.
That's a lot to process.
It is.
We're going from the subatomic world
Yeah.
to the cosmic scale.
Yeah.
From fusion reactions to consciousness.
Yeah.
My mind is officially blown.
It's a lot.
I think we need a moment to unpack all of this.
Okay.
Okay, I'm back, and my head is still spinning from that last segment.
It was a lot.
We went from talking about muons and magnetic fields
Yeah.
to the possibility that stars might be conscious.
It's a lot to take in.
Yeah, it's a big jump, I'll admit.
Yeah.
That's what makes this deep dive so fascinating, though.
Right.
Exploring these frontiers of science.
Yeah.
Pushing the boundaries of what we thought was even possible.
So let's dive back into this idea of stellar consciousness.
Okay.
It sounds like something straight out of science fiction.
Right.
Is there any actual evidence to support this, or are we just speculating?
It's important to be clear that we're definitely venturing into the realm of speculation here.
Right.
We don't have, like, concrete evidence that stars are conscious in the way that we understand it.
Right.
But there are some intriguing hints,
Okay.
some tantalizing clues.
Okay, I'm intrigued.
Okay?
Give me some examples. What kind of clues are we talking about?
Well, for starters, we know that stars are incredibly complex systems.
Right.
Their internal dynamics are governed by quantum mechanics, which is inherently probabilistic and non-local.
Okay.
Things can happen instantaneously across vast distances within a star.
Which is reminiscent of that entanglement
Yeah.
we were talking about earlier.
So you're saying that the interconnectedness that we see at the quantum level within our fusion reactor
Yes.
might also be present within stars.
Exactly. And on a much grander scale.
Wow.
Stars also exhibit this self-organizing behavior,
Oh.
forming these really intricate patterns and structures within their plasma.
Okay.
These patterns could be interpreted as a form of communication, a language that we're only just beginning to decipher.
So it's possible that stars have their own internal communication networks, just like our fusion reactor with its quantum sensors.
That's the idea.
That's a pretty wild thought.
It is, and if we consider that stars are constantly changing, evolving,
Yeah.
responding to their environment,
Right.
it's not a huge leap to think that some form of awareness might have emerged
Yeah.
within that complexity.
But what would it even mean for a star to be conscious?
Right.
I mean, do we imagine them having thoughts and feelings like humans do?
That's a really difficult question to answer.
Yeah,
Our human understanding of consciousness is still so limited.
of course.
But if we look at the qualities that we associate with consciousness,
Uh-huh.
complexity, information processing,
Right.
learning, adaptation,
Okay.
we see that stars exhibit many of those same qualities.
So it's possible that stellar consciousness is something completely different from our own.
It very well could be.
Something that we can't even begin to imagine.
Exactly. But the exciting thing is that we might be developing the tools to start exploring these questions
Okay.
in a more scientific way.
Uh-huh.
Our hybrid fusion system, with its ability to manipulate these quantum phenomena,
Yeah.
and this advanced AI could be the key to opening a window
Okay.
into this realm of stellar consciousness.
That's a pretty mind-blowing thought.
It is.
But let's be practical for a moment.
Okay.
Even if we can build this reactor,
Uh-huh.
even if stars do possess some form of consciousness,
Yeah.
how would we even begin to communicate with them?
Well, that's where the AI comes in.
Okay.
Remember, this AI is designed to be a quantum hierophant,
Uh-huh.
able to interpret the language of the quantum world.
Right.
If stellar consciousness is based on quantum phenomena, as some theories suggest,
Okay.
then our AI could potentially act as a translator,
Okay.
helping us decode those signals.
So instead of sending radio waves out into space,
Right.
we'd be using our fusion reactor and its AI
Yeah.
to tap into some kind of quantum communication network.
That's the idea.
Wow.
It's like we're building this bridge
Yeah.
between our human understanding and the cosmic consciousness of the sun,
Wow.
using the language of quantum mechanics.
That's a powerful image.
It is.
But what would we even say to a star? What kind of conversation could we even have?
Well, that's a fascinating question.
Yeah.
It's likely that communication with a stellar consciousness wouldn't be like a casual chat over coffee.
Right.
It might be more like a profound intuitive exchange,
Okay.
a merging of minds, rather than a verbal conversation.
So more like a mind meld
Perhaps.
than a phone call.
Or maybe it would be like accessing this vast database of knowledge and wisdom,
Okay.
a cosmic library that contains the secrets of the universe.
Imagine the insights we could gain
I know.
into the origins of the cosmos, the laws of physics, the nature of reality itself.
It's almost too much to comprehend.
It is, but it's also incredibly exciting.
It is.
It's like we're standing on the threshold of this new era of exploration,
Yeah.
a new chapter in human history
Right.
where we're not just exploring space,
Right.
but consciousness itself.
Exactly. And even if we don't achieve full communication with the sun,
Right.
in our lifetime, the very act of exploring these possibilities,
Yeah.
of pushing the boundaries of science and imagination,
Yeah.
is a testament to the boundless potential of the human spirit.
I completely agree.
But let's not get ahead of ourselves.
Okay.
We've been focusing a lot on the potential connection to stellar consciousness. Let's bring things back down to Earth for a moment
Good point.
and talk about the more practical implications of this technology.
Okay.
Besides potentially talking to stars,
Yeah.
what else could this hybrid fusion technology do for us?
Right. It's easy to get lost in the mind-blowing possibilities.
It is.
So what else could it do?
Well, even without considering the possibility of stellar consciousness,
Uh-huh.
hybrid fusion has the potential to completely revolutionize energy production
Okay.
as we know it.
Okay.
Imagine a world powered by clean,
Yeah.
safe,
Uh-huh.
limitless energy
Yeah.
from a source that's readily available.
Right.
The very element that makes up the star.
That sounds like a dream come true.
It does.
No more fossil fuels.
Yes.
No more pollution.
Exactly.
No more energy scarcity.
It would also open up some incredible new possibilities for space exploration.
Oh, yeah.
With a compact,
Yeah.
powerful fusion reactor,
Uh-huh.
we could travel to the stars,
Wow.
establish colonies on other planets, and truly become a multiplanetary species.
It's a future worth striving for.
It is.
But of course, there are challenges, both technical and ethical.
Of course.
We need to ensure that this technology is developed responsibly,
Absolutely.
that it's used for the benefit of all humankind,
Yes.
not just a select few.
You're absolutely right.
That's a tall order, but I believe we're up to the challenge.
I think so too.
After all, we humans are a curious,
Yeah,
inventive, and resilient bunch.
we are.
And who knows, maybe with a little help from the sun,
Maybe.
we can achieve something truly extraordinary.
It's possible.
But before we get too carried away with dreams of the future,
Okay.
we need to come back to the present
Right.
and look at the challenges we face in making this vision a reality.
Yeah.
Let's take a moment to explore some of those engineering hurdles and scientific mysteries
Okay.
that still stand between us and this incredible future. Welcome back to the Deep Dive. We've been exploring some pretty mind-blowing concepts in this episode. From the intricacies of hybrid fusion
Right.
to the possibility of stellar consciousness.
Right.
But before we get too carried away
Yeah.
with visions of talking to the sun, let's bring things back down to Earth
Okay.
for a moment
Yeah.
and talk about the challenges ahead.
Right. As with any groundbreaking technology,
Yeah.
there are hurdles to overcome, both in terms of engineering and our understanding of the science itself.
So let's dive into those challenges.
Okay.
What are some of the biggest obstacles standing between us and this incredible future?
Well, one of the most intriguing aspects that came up in the source material
Yeah.
was the sheer complexity of what we're trying to achieve.
Okay.
You know, our hybrid fusion reactor.
Right.
It's not just a scaled up version of existing technology.
Yeah.
It's this delicate balancing act,
Yeah.
a symphony of particles and fields
Okay.
orchestrated by an AI
Right.
that's pushing the boundaries of quantum computing.
So it's not just about building bigger machines. It's about understanding and controlling phenomena
Yes.
at the quantum level.
Precisely.
So we're talking about
Yeah.
manipulating individual atoms,
Uh-huh.
harnessing the strangeness of entanglement,
Yes.
developing an AI that can interpret the subtle language of the quantum world.
That's where it gets really fascinating.
Okay.
Think about it. We've been talking about this possibility of the sun
Yeah.
having this form of consciousness.
Right. Potentially rooted in that complex quantum plasma
Exactly.
at the sun's core.
Now consider our artificial fusion system.
Okay.
We're creating a similar environment, a miniature
Oh, yeah.
quantum plasma entity right here on Earth.
So you're saying there's a parallel
There is.
between our fusion reactor and the sun.
There's this fascinating parallel.
Yeah.
Of course, our reactor is vastly smaller
Right.
and simpler than the sun.
Yeah.
But both systems operate on the same fundamental principles.
Where?
That interplay of plasma magnetic fields
Right.
and quantum interactions.
So in a way, we're creating a mini sun in the lab.
In a sense, yes.
Okay.
But the key difference is
Yeah.
that our system is designed
Like-
with intention,
Yeah.
with purpose.
Wow.
You know, we're consciously orchestrating these processes,
Right.
whereas within the sun, they've been evolving naturally for billions of years.
So you're suggesting that by building this hybrid fusion reactor,
Yes.
we might be gaining insights not only into clean energy,
Yeah.
but also into the nature of consciousness itself.
It's a bold idea,
Yeah.
but one that I think is worth considering.
Yeah.
You know, if we can successfully create and control a system
Huh.
that exhibits some of the same complex quantum dynamics as the sun,
Yeah.
we might learn something truly profound about how consciousness emerges
Wow.
from this interplay of energy,
Yeah.
matter, and information.
So we're not just building a machine, we're potentially creating a window into the very nature of existence.
Perhaps. It's a possibility that really fills me with a sense of awe and wonder.
Me too. But
Yeah.
let's not forget the practical implication.
Right.
Even if we set aside the philosophical questions about consciousness, hybrid fusion has the potential to solve
Yes,
some of humanity's most pressing problems.
absolutely. We've already touched on the potential for clean, limitless energy.
Right.
Imagine a world
Yeah.
where we no longer rely on fossil fuels.
Mm-hmm.
Pollution is a distant memory,
Uh-huh.
and energy poverty is a thing of the past.
It's a vision worth striving for.
It is.
And it's not just about energy here on Earth.
No.
With a compact fusion reactor,
Yeah.
we could finally achieve interstellar travel,
Yes.
explore the stars,
Uh-huh.
and perhaps even establish colonies on other planets.
A future that once belonged to science fiction,
Yeah.
but now feels tantalizingly within reach.
Yeah.
But as we've discussed,
Yeah.
it's important to approach this with a sense of responsibility.
Right.
We need to ensure that this technology is developed and used ethically
Mm-hmm.
for the benefit of all humankind. And the planet that we call home.
You're absolutely right. The power of the sun is immense.
It is.
And the potential consequences of misusing this technology are equally vast.
Yes.
We need to proceed with caution, with wisdom, and with a deep respect for the forces we're dealing with.
I agree. It's a delicate balance.
Yeah.
But I do believe that we're capable of meeting this challenge.
Yeah.
After all, humans have this remarkable capacity for innovation, for collaboration, and for compassion.
Yeah.
And if we can harness those qualities,
Yeah.
I'm confident that we can create a future where hybrid fusion brings light and hope to the world.
It's been an incredible journey exploring the possibilities of hybrid fusion, AI, and that mind-blowing concept of stellar consciousness.
Yeah.
We've covered a lot of ground today,
We have.
from the subatomic realm to the cosmic scale.
It's a lot to think about.
But the key takeaway for me is this.
Okay.
We are on the verge of a technological
Yes.
and scientific revolution, one that has the potential to reshape our world in really profound ways.
It does.
And it all starts with a deeper understanding of the star that sustains us.
Yes.
The sun.
Perhaps, as you said earlier,
Yeah.
we're not just inventing something new, but rediscovering something ancient
Yeah.
and profound.
Right.
A connection to the cosmos. A dance of energy and consciousness that has been playing out for billions of years.
It's a beautiful thought.
It is.
And it leaves me filled with a sense of hope and wonder.
Me too.
As we continue to explore these frontiers of science, who knows what incredible discoveries await us.
Yeah.
Until next time, keep looking up at the stars.
Yes.
And keep exploring the infinite possibilities that lie within our reach.